that is Abdulrahman Kerim.
Yes, hello. So,
Hello.
can you hear me? Let me share my screen and start immediately.
Yeah, thank you.
Hello. First of all, I would like to thank all the community members for organizing this nice event. At the same time, I would like to thank all the presenters for their valuable content. My name is Abdulrahman Kerim. I got my first BSc in Electronics and Communication Engineering and my second BSc in Computer Engineering from Turkey. Currently, I'm a PhD student at Lancaster University, UK. My research interest spans different domains like artificial intelligence, machine learning, computer vision, synthetic data generation, and data mining. I was a full-time researcher in computer graphics and game studies laboratories between 2018 and 2020. Well, let's get started. The work that I'm presenting today is titled Mobile Game Success and Failure, Mining the Hidden Factors. The two authors of this work are me and Dr. Burkay Genc. This presentation will be structured as follows. First, we will have an introduction to the work. Second, we will discuss some similar works to us. Third, we will highlight our novelty and contribution with respect to other works. After that, we will discuss in details the methodology, analysis, and findings. And finally, we will conclude the main points and we will have some discussion and comments. And at the end, I will be very happy to receive your comments and questions. Well, at the beginning, I think it's a little bit hard to judge when the mobile game industry started. However, we can say that when Nokia released its first game Snake in 1997, that was the beginning of this market. And since that date, we can see that the mobile game market was getting more attention and more momentum. Nowadays, when you look to the market, you can see that each day we have thousands of games are being released. However, what's more interesting to know that only a few of them will succeed, while the majority, unfortunately, will fail. Well, before asking what are the factors that cause a game to succeed or fail, we should ask ourselves what do we mean when we say that this game is successful. We argue in our work that looking to the rating average or rating count or revenue alone are not enough measures to judge whether the game is successful or not. However, we need a more abstract, we need a more general measure to do this. Now, in our work, we propose a new success measure that encodes the three main objectives of game development: reputation, the popularity, and revenue. In the scope of our work, we study more than 17,000 mobile games. We do exploratory data analysis to see possible correlations between game attributes and their success. We study the top 100 most and least successful games. We train support vector machine, random forest, artificial neural networks to predict game success. When we look to the literature, we can see a few works asked similar questions to the ones asked and answered in our work. However, what distinguishes each of them is the following. First, the success definition. Second, the studied attributes. Third, the findings and conclusions. Because of time and space constraints, I will discuss only three of them. The first work is Understanding Mobile Game Success, a study of features related to acquisition, retention, and monetization. In this work, they study the top 100 games of Google Play. Number of downloads and revenue was the success. They studied this with respect to 37 different features. Now they found that allowing AIPs is associated with success. However, inviting friends and customizing the game are associated with failure. Second work, titled Mobile Gaming Trends and Revenue Models. In this work, they considered 50 iPhone games. The revenue was studied with respect to 31 attributes. So their main aim was to identify the most 10 important features in game development. As a conclusion, they found a relation between the total number of people who run or get engaged with a game and its revenue. The third work was Determinants of Mobile Apps Success, Evidence from the App Store Market. In this work, a game was said to be more successful than other if it is able to stay a longer time among the top applications as compared to found the following are positively correlated with the success. First, selecting a less competitive genre and keeping the application's quality at higher levels. Now, it's a good idea to compare our work's novelty and contribution to other works. So, first of all, we examine various games' attributes and their effect on average rating, rating count, and also the proposed success measure. Second, we consider more than 17,000 mobile games apps instead of considering a limited number of apps. Third, we define a new success measure. Fourth, we consider mobile games spanning different genres, various developers for free and paid games, and other unique attributes. Finally, we conduct both analytical and predictive studies. In our work, we use the dataset titled 70K Mobile Strategy Games Dataset. This dataset contains more than 17,000 mobile games, and these games were taken from Apple App Store. Each game is associated with 18 different attributes, and a negligible number of these values is missing. This dataset can be considered a new dataset. It was collected in August 2019. Well, initially the main attributes of the dataset are shown together with their types in this table. In the first and third column, you can see the attribute name, like URL, ID, name, subtitle, etc. And in the second and fourth column, you can see the type of this attribute, like textual, numerical, date, etc. Before starting analyzing and studying our dataset, we need to perform a set of procedures to guarantee that we have the most appropriate dataset for our study. First of all, we perform attribute selection. By this, we mean that we select the most relevant attributes to the game success and we neglect the ones that they are not relevant to this. For example, the URL attribute. After that, we handle the missing data. Following this, we drive new attributes to enhance the level of information provided with each single game. Following this, we perform data categorization. We do the data categorization in order to guarantee a balanced distribution of the attributes and the attributes values across our dataset. Since we argue in our work that using only the rating count, rating average, or revenue alone are not appropriate measures to judge the game success correctly, we provide our novel success score measure. As you can see in the provided formula, so in the numerator, we have the rating count multiplied with the expected number of people who will purchase the game multiplied with the initial installation or price of the game. Following this, we add the rating count multiplied with the expected number of people who will buy the in-app purchases multiplied with the average in-app purchases. After normalization, we add it to the normalized average rating. In the denominator, you can see that we have the elapsed time since the game initial release. So, for a game to score high on our measure, it should achieve the highest rating count, the highest average rating, the highest revenue in the shortest period of time. Regarding the models and algorithms used in this work, first of all, we use the a priori algorithm to find the possible correlation between the success and the game attributes. Second, we rank the games in terms of success score, rating average, and rating count. Then, the attributes distribution in the best and worst 100 games were analyzed. Following this, we divide our dataset into three partitions: training 80%, validation 10%, and testing 10%. After that, we train support vector machine, random forest, and artificial neural network model to help us in predicting the game success from the attributes. The used models and their associated parameters are shown in this table, as you can see. Our findings with respect to the success score reveals the following. Being a long-time developer and availability of cheap in-app purchases, publishing puzzle and travel games, and supporting many languages were all positively correlated with the highest score on our success measure. However, releasing the game in July was negatively correlated with the success. When we analyze the best and worst 100 games in terms of success score, we can can conclude the following. First of all, developers are suggested to include in-app purchases as much as they can, and also they are suggested to make their games paid. Otherwise, if they make the game free, or if they don't provide any in-app purchases, their chance of success will decrease very much. Similarly, we can see including in-app purchases and focusing on +9 audience is expected to allow the developer to achieve higher average rating. However, focusing on small size games or free games is associated with low average rating. In terms of rating count, we can see availability of the game in many languages and targeting +9 audience is associated with high rating counts. However, making the game free was associated with the opposite. In the prediction part, we can see that almost all the models achieved around 70% classification accuracy. We note here that predicting our success measure sounds to be much more easier as compared to rating count or rating average. RF model was better as compared to support vector machine or the deep learning model. When we look to the true and false, positive and negatives of the random forest for the 3 scores, the success score, the rating average and rating count, we can see the following. First, predicting the unsuccessful game is much more easier than predicting the successful game. That could be because there is a specific path or a specific correlation with some specific attributes causing the game to fail. However, predicting the game to be successful is much more complex and it's associated maybe with more sophisticated factors. In conclusion, you can see that in our work we have presented some facts regarding the relation between the success of a mobile game and the various game development process attributes. Also, we have presented a new novel success measure that encodes the revenue, popularity, and reputation. Finally, we have shown that some attributes impact the success of a mobile game positively or negatively. Thanks to the reviewers' valuable comments, we are planning to extend our work in different directions. So first of all, as a journal extension to this work, we will extend testing with the cross-validation. At the same time, we will carry more detailed tuning for the parameters of our predictive models. At the same time, we'll include more datasets from different app stores, and also we are thinking to include games icons as an attribute associated with the game as well.
Thank you.
Thank you very much.
Yeah, thank you. Is there any questions from the other researchers? I have a question for you.
Sure.
Yes, I suggest you was mentioning about an extension, a journal, hopefully. And,
yeah.
I wish you luck, of course. Have you designed a kind of experimental evaluation also involving human evaluators? I believe that when you are proposing a new measure, in this case you have a new measure of success of mobile games, you have to ascertain qualitatively if this measure actually captures what a human would say, a human expert would say about these games. So this is my suggestion.
Thank you very much. Yeah, this is a very nice thing. Sure, it could be done. Yeah, thank you very much.
Okay, perfect. Thank you. I
Thank
believe you can stop sharing your
Thank you very
screen.
much.